In the last video, we started talking about different groups in the periodic table and how we can tell their charges. Now it's going to be really important for this next video that we remember the charges and that we use the periodic table to find out information about those charges. So we said everything in column 1, my alkali metals, have a +1. Everything in column 2, my alkaline earth metals, have a +2. Now we didn't add this charge last video, so write it now. In this column, aluminum, gallium, indium, thallium, they're going to have a +3. They're going to lose 3 electrons to form a cation. Now let's skip this 14 row, carbon, silicon, germanium, because it's a little weird right now. So starting with nitrogen, phosphorus, it's going to have a -3. Remember, our non-metals want to gain electrons, so nitrogen and phosphorus will be a -3. We'll talk about bismuth, it's a little bit different later. Oxygen, sulfur, selenium's going to be a -2. We said our halogens are a -1, and then the noble gases don't form ions, they don't have a charge, okay? So it's really important that we remember +1, +2, +3, skip, -3, -2, -1. We need to memorize that, we need to know that, because otherwise naming is going to be really hard, okay? So we're going to start with simple binary compounds. Binary, bi, meaning 2, okay? So a binary ionic has to have ions. It's going to have a positive ion, which remember we called a cation. Our cations are always going to be metals. It's also going to have a negative ion called an anion. And remember, our anions are always non-metals. Okay? Now, when we're naming binary compounds, 2 elements, we're always going to name our cation first. The cation always goes in front, it's always named first, and so we name our metal first, okay? The positive ion just takes the name of the element. I don't have to change anything for it. I look on the periodic table, I figure out its name, okay? I'm going to change the ending on the anion to IDE. So I look up the element name, I name it, I take off the ending and change it to IDE. So NaCl, Na is sodium, I leave the element alone. Cl is chlorine, I change the ending to IDE, and it's sodium chloride. Ki, K is potassium, I leave the name alone. I is iodine, I change the ending to IDE, so it becomes potassium iodide. Calcium sulfide, lithium nitride, cesium bromide, magnesium oxide. Now it's important that you notice, even though I have 3 lithiums here, I don't say anything about the 3 in the name. I just name my first element, I name my second element, and I change that ending to IDE. Okay? So, in example 1, I'm going to name my elements. If I look at the periodic table, Cs is cesium. I leave the name alone. I don't change anything. And then I name F, which is fluorine. But I change that ending to IDE. So it would be cesium fluoride. Okay? Take a second, try example B, AlCl3. What you should have done is look at the periodic table. Al is aluminum. Cl is chlorine. but I change that ending to IDE. It's aluminum chloride. Doesn't matter that I've got 3 Cls, I just name it that way. Okay? Take a second and name C. Looking at the periodic table, Li is lithium. H is weird. H, even though it's on the left side of the periodic table, remember it's a non-metal, so it's not an alkali metal. It doesn't have a +1 charge. Hydrogen can be either a +1, sometimes it is, or it could be a -1. So in this case, because it's my second element, I know it's a minus, so I write hydrogen. Whoops. But I need to change the ending to IDE. Now in this case, instead of hydrogide, I cut it off the O, and it's going to be lithium hydride. Okay? Now going from the name to the formula is a little bit trickier. I need to find the element on the periodic table, but I don't just find the element, I also have to keep track of charges. So potassium is K. K is an alkali metal, so it has a +1 charge. Iodide was originally iodine. Iodine is a halogen. It has a -1 charge. Now, in an ionic compound, the charges need to cancel. So the whole compound, when I add up all my pluses and minuses, needs to be neutral. In this case, I have a +1 and a -1. +1 minus 1 equals 0. It's already neutral. So when the numbers are the same, all I do is I squish my two elements together and I get Ki. Okay? So let's look at calcium oxide. Calcium oxide, I've got Ca. If I look at calcium on the periodic table, calcium's an alkaline earth metal. It's a +2 charge. So I'm going to write +2 next to that. Oxide was originally oxygen, so that's an O. I look on the periodic table. Oxygen was originally a -2. So +2 -2. Because the numbers are the same, all I do is squish them together. Okay. Last one, gallium bromide. Gallium is Ga. If I look at the periodic table, Ga is over here. It's a +3 charge. It's reacting with bromide. Bromide was originally bromine, Br. Br is a halogen, -1 charge. Now, unlike the other two, my numbers aren't the same. When they're not the same, I need to switch them. So what I'm going to do is I'm going to bring this -1, I'm going to ignore the negative, and just bring the 1 and put it in front of gallium. I'm going to take the +3, I'm going to ignore the plus, and I'm going to put the 3 over by bromine. Here's what I'm doing. 1 times +3 is a +3. 3 times -1 is a -3. So if I've got +3 and -3, it'll cancel out. So when I write the formula, I only need 1 gallium, so I could put the 1 there if I wanted, or ignore it. Br, I needed 3 to balance the charges. Okay? So it's really important that I remember my charges, 1, 2, 3, -3, -2, -1. Otherwise, I'm not going to be able to write the correct formulas. Anytime I have a binary ionic compound, I'm going to have to write the formula based on charges.